guys, video 21.1, factoring part 2. I know you should, I feel your pain because this is one of my favorite topics, so hopefully I won't go yakking on you. Alright, we're still doing factoring, okay? And I'm so bad about putting the directions up there. This is factoring, alright? And remember, I want you to get in the habit, even though in that last one we didn't have a lot of GCF, always look and see if there's a GCF. All right, I swear I'm fine. All right, GCF, here we go. All right, 6 is even, 72 is even, 162 is even. I know 6 can go in there. Yeah, the GCF must be 6. All right, and then remember what you do. Once you get the GCF, you divide each terms by the GCF. It'd be funny if I'm wrong, but I'm pretty sure I'm taking a good guess here. All right, 6 on the outside, x squared. All right, 72 divided by 6, that's going to be what, 9? All right, let me type this in here real quick. 72 divided by 6. I'm sorry, who said 9? How about 12? Yeah, right. So there's 12x. And then the one I really don't know is 162. 162 divided by 6. All right, and that is 27. All right, this is why I use a calculator, just to make sure. All right, I'm on camera here. I'm trying to be as, yeah, I hear y'all. Okay, so when you see the F word, okay, always look to see if there's a common factor that can be divided into all three. In this case, it was 6. Pull the GCF out here. This is x squared, believe it or not, that's 12x, like I always said, okay, plus 27. Now, before you call it a day, this could be the answer. We have to check this trinomial here. So leave 6 alone. We're going to try to do the 2 sets of parentheses. A lot of times they'll factor again. You're going to circle 27, and you're going to go 1 times 27, 3 times 9. You're looking for the magic pair that will add up to 12. Here we go. I'm going to put my x's in here. What was that? Oh yeah, 9 plus 3 is 12. Doesn't matter where you put the 9. Doesn't matter where you put the 3. If this is positive and this is positive, these are all positive. What? And there you go. That's a work of art, isn't it? Okay, that was example 1. Let's try another one. Okay, here we go. Example 2. You spin me right round, apparently. There we go, and you get another problem. All right, here we go. GCF. I'm going to go with 5 because I know 5 and 15. Yeah, 5 will go into 90. All right. Is there anything else that can go into all 3? So you've got 3 n's, 2 n's, 1 n. The most n's that all of them have at least is 1 n. So you're going to divide by 5n, divide by 5n, divide by 5n. All right, now the 5's cancel here, and when you're dividing monomials, you subtract. So this is n squared minus 3n minus, is that 18? Someone double check, because they made a mistake last time. Don't know who that was. Yes, very good, 18. Wrap that baby in parentheses and put your GCF out here. Okay? Before you call it a day, let's just make sure. A lot of times these trinomials here will factor again. So n squared is n times n. Circle your 18. Oh, someone already yelled it out. Okay, I like it. 6 times 3. Okay, you're right. And this means the signs are different. But what kind of 3n do you want? You want a negative, so the higher, 6 versus 3, you put the negative here and the positive here. All right, let me back away for just a second. Make sure you're good. What's that? You need more fun? Okay, let's try this one. Example 3, we're still doing the F word, factoring, factor. Always look for GCF. Now, what do you notice? They don't both contain an x. You can't divide both by 5, so there's no GCF to worry about. Technically, it's 1, okay? But when you divide by 1, it doesn't change it. It is not a trinomial, but you do have that quadratic term there. So always try with the 2 sets of parentheses. You're going to put an x here, you're going to put an x here. You're going to circle 25, and honestly, you don't have to stress this one that much. You'll notice that 25 is a perfect square. It needs to be a perfect square. because you're gonna put 5 and 5 in here. Look, you're missing that normal middle term to get it to cancel out. Look, one's gonna be positive 5, one's gonna be negative 5. This one has a name. This problem right here is difference of two squares, and then it will factor into what they call conjugates, okay? So you can square root x squared, put x there, square root 25, put 5 there and there, and make sure the opposite signs, okay? Stay with me, stay with me. Difference of two squares. All right, how about example 4? So I know 3 can go into 9, but it can't go into 25. And 5, so there's no GCF to worry about. Very good. 9 is a perfect square, and 25 is a perfect square. So cool, they threw an extra number in there, but you're right, 9 is 3n, and then another 3n, and then 25 is also a perfect square because it's 5 and 5. And in order to get that middle term to cancel, one's got to be positive, one's got to be negative. Okay, I'm going to circle this answer, but again, I see that doubt in your eyes, so I'm going to take your answer. Okay, remember, what you're really doing is you're just going backwards. If you were, this is the answer, but if you were to work this out, remember, the first term times the first term, or 3n times 3n is your 9n squared. Then if you distribute this, that's your negative 15n. If you distribute the inner one, it's a positive 15n. And then if you distribute those two, minus 25. Well, look, nice and convenient. Those middle terms cancel, and you're just left with that. Okay? So just keep that in mind. All right, let's try another example. Again, it's called difference. Difference of two perfect squares, or difference of squares. And it will factor into two terms that look the same, but one's a sum, one's a difference. All right, here we go. Our next one that has a name. Look at this baby, number 5. Looks nice and innocent. Yeah. All right, no GCF, trinomial. Try your two sets of parentheses. This is x, this is x. Factors of 9, 3 and 3 will work. Okay, when this is positive, same. Okay, positive, same. Negative 6 means you make them both negative. Okay, so look, this one factors into a term times itself. Okay, so you can leave it like that, but you know they're going to shorthand it and just go x minus 3 squared. This is called a perfect square trinomial, and it factors into a binomial squared. Okay, we're good? All right, one more, I promise, one more out of this set. All right, no GCF. See, a lot of times there won't be a GCF, okay? 9, yes, perfect square. 1, yes, perfect square. So both of these are perfect squares. Let's just see if it'll add up to that 6b, but I think it's gonna be worth trying it. It's a nice educated guess. So 3b times 3b, 1 times 1. And yeah, look, that's going to be a 3b, and this is going to be a 3b, so that's going to give you that 6b in the middle. So you make them both positive, all right, and then finally you have 3b plus 1 to the second power. Woohoo! All right, I hope this helps. This was video 21.1, factoring part 2. We will holler at you later.